All right, so today we are going to cover 3.7 part 2. In part 1 of 3-7, we had equal signs. We had equalities or equations. So we did not have to worry about the ands or the ors. When we got our solution set, it was just two unique points that were our solution. Now moving on to part 2, we're going to have inequalities now. I highly recommend you write this in your notes because this is going to be a lifesaver for this chapter. What it's saying is that if in our inequality our absolute value is on the left of our inequality symbol, then this is true. The absolute value has to be on the left of our inequality for this to work. Remember that you can move it if it's not, but just if you're switching your sides around, remember to flip your inequality. If your absolute value is on the left of your inequality and you have a less than or a less than or equal to, then when you graph, you should have an and, which means they are going to meet in the middle. If your inequality symbol is greater than or equal to, you are going to end up with an or, which means that when you graph, your arrows are going to point out. The other important note that you need is that for the negative, number, you flip the inequality. So let me show you how this works. If we had 8n in absolute values and then greater than or equal to 24. We have our absolute value. It is on the left of our inequality, which is good. We have greater than or equal to, which says that this should be an or when we solve it out. So let's do that. The absolute value is alone on this side of our inequality, so we can go ahead and split. Remember that with your negative number, so if we make this our negative 24, this needs to flip around. So we're going to say an is less than negative 20, less than or equal to negative 24. And then on this side, we keep the inequality the same, greater than or equal to positive 24. Go ahead and solve these. Just remember that we're dealing with inequalities now. So if you are multiplying or dividing by a negative number on both sides of your inequality, you have to flip your inequality. We're not doing that right now. We're dividing by a positive number, so we don't need to worry about that. And we get this and this. So now that I have those solutions, I can graph them. Notice they're not just two unique numbers like when we were doing the equations in the last section. They are solution sets. So we have n is less than or equal to, it's going to be a closed circle going left, negative 3, and n is greater than or equal to 3. So we have that. Notice when we graph this, we did in fact come up with an OR graph where those solution sets do not overlap. One is going to the left, the other is going to the right, and there's that gap in between of things that would not work. So when you do your checks here, you need one that's on this end, one in the middle, and one over here. So we are going to take this and write it 3 times. And we're going to go ahead and plug 3 different things in. We want one to be on the true side over here, one to be on the false side in the middle, and one to be on the true side over here. So I am going to pick negative 4, Oh, 4 would be over here. And I'll put 0 in the middle. That's absolute value. So over here, you get the absolute value of 32, which is 32. Remove this. Oh dear. 32 is greater than 24. So that's good. Here we get the absolute value of 0, which is 0, is greater than or equal to 24. That is not true, which is perfect because it was in the middle where it should not have been true. Over here, we will get the absolute value of 32, which is 32 is greater than or equal to 24. That also is true. So we have 2 good checks. Those were on either side. And then the not good check, the wrong check, which was in the middle and should not have worked. So that was perfect. If you're dealing with your an and equation, you can do 1 good check and then your not good checks should fall on the outside. So with the ands, you would have 2 good checks. Add that to our chart here. We'd have, oh, here we'd have 2. Let me do 1 wrong and 2 correct. So your checks for and, you would have 1 wrong. I did that wrong still. You'd have 2 wrong and 1 correct. So the 1 correct would fall somewhere in here, and then you'd have a wrong on either side. For the ors, you're going to do 1 wrong and 2 correct. That's the one that we just did. So we had 1 that was wrong. Whoops. This one in the middle was wrong, and the 2 on the outside were correct. So with the and, 2 wrong checks, 1 correct check. With the ors, 1 wrong check and 2 correct checks. You're going to have 3 checks for each of these. I want you to pause your video, try Got It 4, and then come back for that explanation. Our Got It 4, we again have a greater than or equal to, which means on our chart we're going to have an or solution, meaning our graph should go out and not meet in the middle. Our absolute value is already isolated, so we can go ahead and split our inequality. Remember that when you're doing the negative version, you need to flip that inequality. The positive version is going to stay the same. We have a 2-step inequality here. We need to solve. Divide everything by 2, and we get x is less than or equal to -9. Oh, I forgot to actually divide there. Whoops. So it's 9/2. And then x is greater than or equal to 1/2. So when I graph this, my negative is going to go on the left. I have closed circles, and x is less than or equal to -9/2. X is greater than or equal to 1/2. So you can see I do have my OR solution. I am then going to check using 3 checks, checking each section of my graph. So I need something that is less than -9/2. I could in fact use 9/2 because it's or equal to that closed circle, meaning -9/2 is part of our solution set. I'm going to use something smaller though and say, we'll just say negative 11 halves. So when we do that, these halves cancel out. We get negative 11. And copy the rest. If I add that, I get negative 7. Absolute value would be 7. 7 is greater than or equal to 5. That is true. Here I want to use something that's not going to work, so I'm going to use 0 because that's between the two numbers. I get 4 is greater than or equal to 5. Not true, just like we were hoping. And then I need something that's greater than 1/2, so I'm going to use 1 here. That would be 6. And 6 is in fact greater than or equal to 5. So again, 2 correct checks, 1 incorrect check. And that appears to be a great solution here. We have an OR, so it is x is less than or equal to negative 9 halves, or x is greater than or equal to 1/2. That would be our complete solution set for Got It 4. These, you can see, are inequalities that you have to do quite a bit of work for. I'm hoping this is helping you feel comfortable that you're going to be set up really well for your algebra class next year. We have one more example here, problem 5, which is a word problem. It says, oh, and this is also a less than or equal to, which means it's going to be an and. So our graphs for this one should come in and meet in the middle. Let's see, it says a company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weights for a box of crackers? So we can say that the weight of the box minus 213, which is what it should weigh, and put absolute values around that. That means that it can be less than 5, 213 less than 5 grams or plus 5 grams. It works both ways. So if we say the weight minus 213 in absolute values, and that can be less than or equal to 5, because it said can be, let's see, any box that varies from the weight by more than 5 grams would be set up. So 5 grams is okay, either smaller or bigger. When we do this, our absolute value is already isolated on that side of our inequality. So we can go ahead and split this. Remember, with your negative 5, you have to flip that inequality. With the positive 5, the inequality stays the same. And then everywhere we are adding 213. And we get W is greater than or equal to 208. And W is less than or equal to 218. So we can graph this. Close circles because we have the or equals to, and that is what our graph looks like. When we check this again, we're going to have 3 graphs, but this time 2 will not work and 1 will work. So when we do this, we need 3 graphs, or I'm sorry, 3 checks. For my left check, I'm going to use 200. 200 would be over here. Sorry, I was trying to think of something that would work well. So when we subtract here, we would get the absolute value of negative 13, which is 13. 13 is not less than 5, which is good that it did not work because it's off of our solution. Here we can use, say, I'm going to use 215. Which should be 2. 2 is less than or equal to 5, so that's a good check. Over here, I'm going to use 220. 7 is less than or equal to 5 is not true. So you can see we do have 3 checks that are proving what we needed them to prove. We have 2 that didn't work that were outside of our graph, and then 1 that was inside our good range that did work. So we have shown that our solution set is good. Remember that with the AND solutions like this, you can actually combine both statements into one. So we can, when we solve these out, we can leave our W minus 213 in the middle, and then we have less than or equal to 5, and on the other side we have our negative 5. And when you do this, remember that these inequalities are always going to be less than facing that way. So either less than or equal to are always going to show up here. And they do in this case as well. If we think about moving this down here, we are switching that to the left side, so we have to flip our inequality over, which we have done here. And we have our negative 5. So if you are solving this way, remember it's handy because you can do it all together. Just remember you have to do it in each section of your inequality. When you do this, we get our nice, neat solution set, which you'll notice would lead to the same graph, same checks as we had here. This is just a combination of this same solution. Down here, you would not have to use the word and because you're already showing that it all goes together. Up here, you do need and because you have these 2 distinct solutions. And on the graph, it shows that they do come together in an and. But if you're leaving those separate, you would need the word and. If not, you can do it like this and get that nice, neat solution set from the start. 208 is less than or equal to W is less than or equal to 218. I would like to do one more of the, I lost my page, one more of these and ones for you. I think the or ones you're probably going to be okay with because they do actually just stay separate and you solve them out. With the ands, however, combining them, I want to show you one where we combine from the get-go so that you can see how that looks. So in your lesson check, I'm going to do number 2. You can see it is a less than, which means this is going to be an and. When we set up an and, which is going to be anything where your absolute value is on the left and you have less than, or you could have less than or equal to, and this will be an and. So we're going to put what's in our absolute value in the middle, and then we do this. So we have 2 less than signs, we have 5, and we have negative 5. When we solve this out, remember to add 3 to each part of your inequality. And we right away get our solution, which is negative 2 is less than h is less than 8. We can graph that. And we have open circles this time. And because it's an and, we know that they're going to connect in the middle. We can check that by reading this way. H is greater than -2, which it is, and H is less than 8, which it is. So we're good there. Now we do our checks, one in each section of our graph. So I'm going to pick something that's less than -2. This one should not work. I'm going to pick -3 here, which should not work. And we get 6 is less than 5, which is not true, so that's good. We can use 0 in the middle. We get 3 is less than 5, that is true. That's in our graphed area, so that's good. Now to try something bigger than 8, I'm going to use 9. We get 6 is less than 5, which is not true. So with our ands, we're looking for 2 checks that are not true and 1 that is. And we got that, which shows that we got number 2 correct. What I would like you guys to do next is work on page 228, 7 to 19 odd. So you are going to do this assignment and then check back to your coursework section on Rediker for my video where I go over those problems for you.